All right, I am your host, Mr. Sindel. Today we are in AP Calculus. Let me change the window here. Today's date is Halloween. It is 10/31/2019.
Can we just write Halloween in the date box?
Sure, say Halloween. We are talking about circular related rates. This is our first lesson on related rates. What is our objective today?
Solve related rate problems dealing with the area and circumference of circles.
There it is. Let's make sure that we know what the area and circumference are. What is area? What is the formula for area? Shout it out. Pi r squared. You have to have that memorized. It's one of like the 3 things you have to have memorized this unit. And you already have it memorized, you're done. Nice. All right. Circumference is the second of the 3 things that you need to have memorized.
Circumference equals. There's a D in there.
There's pi, it's like
R
pi
squared. R
diameter.
squared. 2 pi r?
It's diameter, isn't
Oh.
it?
2 pi r is the normal one. I mean, some people will give the one that's pi times diameter, which is okay, but usually you want to do 2 pi r because they're never, almost never, going to give you a problem where they give you diameter. And if so, just convert it to radius and then you're good. And then finally, radius in terms of the diameter is what?
Pi r.
Wait. That's,
What?
no. So in terms of the diameter, the radius is,
Pi.
Is 1/2.
it's half of the diameter. So it's diameter divided by 2.
Oh, wow.
I think Halloween's messing with everything.
Oh, blame Halloween.
Yes.
And
You
I
know what,
didn't-
Joe? Anything situational, I'm going to blame.
Your hair's in there. I
Don't
know.
look
It's
at it,
super annoying.
Just make sure that you know that A stands for area. I mean, it's pretty straightforward. This is area, this is circumference, and R stands for radius. All right, we know what all those letters mean. So let's talk about what happens when you take the derivative. And I'm going to be taking the derivative with respect to time for most of these related rate problems because it's a rate. So how fast over, like how far versus how much time you're doing. So everything is going to be dt. But we're going to ignore that for now. Area again is pi r squared. What happens when I take the derivative with respect to t? Pi r squared. Notice I don't have any t in here, which means it's very like a y problem, where if I have a y squared, then it turns into y, or 2y, y prime. 2y, y prime. You're going to have lots of like r primes in these guys.
Pi r prime.
There it is. 2 pi r prime. And I know a lot of AP calculus teachers say, oh yeah, just memorize your a prime and you're good to go. I mean, it doesn't really matter. Memorize area of the circle and you're good to go. You just have to take the derivative again. There is a trick for these types of problems though. So if I have circumference again is what? 2 pi r. And derivative is going to be, with respect to t again, is
2 pi r prime.
2 pi r prime. Perfect. Do you guys notice something similar between circumference prime and area prime?
There's also r prime.
It's just the R.
Yeah, the only additional thing is the r, and it's the same thing. 2 pi r prime with the addition of the r. So if you kind of underline or say that this all right here, that is c prime, which means a prime can also be rewritten, and this will save you lots of time if you can remember this. A prime is c prime times r. It is pretty cool. Oh, and I even gave you a space for that down here. A prime is c prime times r. All right, so I think I only have, is it one example? Do I have anything on the, oh yeah, and then units. So one example that you might see, and it's just kind of setting up the problem and taking the derivative and filling in the blanks, doing substitution. Who wants to read? Thank you, Arrow. Go for it. Her mouth was like, I'm about to say something, even though I'm really yawning.
Okay, oil spilled from a tanker in a circle. Wait. Entirely reading stuff here. Whose area increases at a rate of 40 feet per second. How fast is the radius increasing when the radius is 50 feet?
All right, so analyzing this problem, let's first see what is it even asking for. It's asking for how fast is the radius increasing. So this thing right here, I'm going to try to color code this as much as possible. How fast is the radius increasing? What is it talking about? Is it r or r prime here? Someone shout out. Is this r or r prime?
R prime.
This is r prime. So we can say that r prime is the question. So r prime, I'm going to say that's the box. I'm going to eventually fill that box in with whatever. You can say r prime is equal to question mark. Whatever you want to do, as long as you analyze the problem to know what it's asking. What information is given? And give me a variable with what that variable equals.
You have the radius.
I have the radius.
Which is 50 feet.
So what variable should I have for radius then?
R.
So we know that r is equal to 50. And I'm going to ignore units until the very end. That's generally the way that AP Calculus problems work. And then finally, I also know what? I have some 40 right here.
Oh, that's A prime.
R prime is equal to 40, right?
No, that's A prime.
Area increases at a rate. So area is increasing at a rate. If it's talking about a rate, it's talking about the derivative. If I'm talking about the derivative of area is 40 feet. So I say that area prime is equal to, is it positive or negative 40?
Positive.
Why is it positive 40?
It's increasing.
Increasing. Okay, so that's a positive word. Sometimes you'll have a negative word. Decreasing will mean I'll have negative 40. All right, so obviously I'm using area and radius. What's a good formula that uses area and radius?
Area prime equals
I don't even go backwards even further than that, right? Area is equal to pi r squared. And then, Claire, do yours.
area prime is equal to circumference prime times r.
That would help us if we were given circumference. Let's just do the default one.
Oh. 2 pi r.
2 pi r prime. Yeah, if they give you their circumference is at a rate of whatever, then yeah, definitely use that formula. If they gave you like a c prime, then you'd use that formula. All right, so let's fill in what we know. Do we know a prime?
Yes.
What is it?
40.
All right. Do we know, we know 2. We know pi. Do we know r?
Yeah.
What is r? 50. Do we know r prime?
No.
Okay, so we're just going to leave that as r prime. All right, and then solve for r prime. Again, that's what the question was asking for, so let's just throw everything to the other side of the room. We're dividing by 100 pi on both sides. So divide this side by 100 pi. Why am I dividing by 100 pi? Someone tell me.
That's 50 times 2.
50 times 2 is 100, and then there's the pi. So if I divide both sides by 100 pi, that should cancel out, that should cancel out, that should cancel out, and we are left with r prime is equal to, reduce this fraction, 2 over 5 pi, and what would our units be?
Feet
Feet
per second.
per second. Why isn't it just feet? Isn't this radius?
It's a rate.
Okay, so one of the key things when it comes to related rate problems is getting the units right. You actually get a whole point just getting the units right. So if you get your units wrong, you lose a point. And I'll talk about points in a second. Well, not in a second, but like in this unit, I will be talking about how scoring works because related rate problems are they can be multiple choice or they will always be free response as well. So get ready for both forms of those. So let's assume I was talking about area. What would my unit? What would be an example of units for area? Let's assume we're always in meters or something. I don't know. I like metric.
Alright.
What would be a unit for area? Meters? No, meters squared because I'm always in the second dimension for area. What about circumference?
Meters.
Meters, good. It's just a length. What about radius? Meters, good. What if I'm talking about a prime?
2m.
No.
No?
Meters squared per second.
Meters squared per second. Or per minute, or per time. Some time. I just randomly chose seconds. Again, whenever I'm talking about a prime, I'm talking about a rate. How fast are things happening? Therefore, if I'm talking about c prime, I'm talking about meters per second. And geo, if I'm talking about r prime, I have
Meters per second.
meters per second. What if I'm talking about the second derivative? How fast am I accelerating? What is or not how fast am I accelerating? It is indeed
Yeah.
meters squared per
second. Oh, yeah.
second per second. Or instead of saying per second, you can just say per second squared.
Could you also theoretically do the quantity of meters per second squared? Like m divided by second, and then in parentheses, and then a square.
Like, you want to put parentheses right here?
No, never mind. It doesn't make sense.
Okay. And I will write this note because sometimes I will randomly do this, and I want to make sure that everyone knows. Meters squared per second squared, and that's, I can write this a little bit neater, per second squared is the same thing as meters squared per second per second. All right, what about circumference, the double prime?
Meters per second squared.
Meters per second squared. And Sego, finally, r double prime. There it is. Make sure you get the correct unit. So if I'm talking about how fast is the circumference changing, you would just give me some sort of unit like what? Meters?
Yeah, meters.
Meters per second. If I said, what is the area, you'd give me something like?
Meters squared.
Perfect. Okay, so I'll be quizzing you on units every single time that we do the notes. Make sure you have all the units correct on your homework. It's something to be checking for. When you're checking over your answers, be checking units. It is an important topic, although not as important as the numbers, but it is still important. It is worth points. All right, and that's the end of the lesson.